Yeah, good morning to all. So we are completed the theory parts of the module second, and one problem. Some of the exams we did, and the second problem in the textbook that is given as a homework. I think that I didn't get a chance to clarify, or I didn't get a chance to explain it. So today we will continue from problem number 2. So here, when you are observing the block diagram, you can see that there is a feedback divergence from this point. So when you are doing the reductions, you should see that if you are moving this to here, this branching, if you are moving from here to here, it is more easy to do the reduction. So first thing, we have to move this branching before G2. Now when you are doing like that, what is the problem? When you are doing like that, what is the, because since the signal is passing through or I think that the signal is passing through this branch, is passing through G2, and if we are keeping this branching before this G2, then this branching do not have an opportunity to pass through G2, so we will provide an option to pass through G2, so that you can see in the next diagram. Yes, so here, as you can see, we moved branch to here, so we are multiplying with the G2 and previous H1. Now here you can see that these two are in cascade, so you can just multiply it. So that you can see in the next diagram. Apart from that, what you can see in the diagram is, yes, this you can multiply, and you can see that this is a feed forward branch. Here also it is plus, here also it is plus. So what you can see, G1 G3 plus G4, if you are reducing this entire block, it become G2 G3 plus G4. So after the reductions, you are getting like this: G2 G3 plus G4, and after that this feedback, then again here again one more feedback. So here what you need to do is, you have to here what is the problem with the diagram is, here one summation is that after that a branching. So it is better to move this branching after this block. So what exactly happening is, actually before it means it is not passing through, after this it is passing, that is multiplying with this. So in order to compensate that effect, what you need to do is, we have to divide this, because if you are keeping away this, actually from here it is taken. But if you want to take the branch after this, what you need to do is the signal here, that is multiply by this, and you are getting here. From there, if you are taking, so when you are comparing the signal here and here, an additional multiplication happening with this, additional multiplication of this is happening. So in order to compensate that, if you are taking the branching from here back, then what you need to do is you need to divide this, because in order to compensate, so that you can see in the next diagram, G2H1 divided by G3 G3 plus G4. So apart from that, I think that, yeah, apart from this everything is same, only that we are done here. Now as you can see here, we can this is again a simple reducible feedback section. So we can reduce that, the summation, everything you can eliminate it, so that you can see in the next diagram. Yes, here. So that is nothing but, as you can see that when you are what is the effect of that? What is the effect of this? So you know that G1 how you are getting it? Could you just explain to me, when you are reducing a simple feedback system, you will get it as numerator G2 G3 plus G4 divided by 1 plus G2 G3 plus G4 into H2. This is general formula. As you are aware that this is general formula, as you are aware that, so when there is a feedback system, with the G and H, and it is given back. Okay, so here if this is plus and this is minus, then you will get it as this as G divided by 1 plus G into H, since it is minus, so you are getting it as G divided by 1 plus Gs. The same applications, same formula we used here, so it is reduced to like this. Now after that, it is very clear, these two are in cascade, just to multiply it. Okay, just to multiply, then you can see that this and this again the same feedback. So what you need to do is you can reduce this by, yeah, you can buy a single block. Here it is just multiplying this and this. You can see that here it is just sorry. Now here this just multiplying these two, you are getting this. Yeah. After that, this is considered as a single element, this is a feedback element. The same formula what I explained, same you have to apply it, then you are getting this with a feedback system with a no feedback element. So this is nothing but this term divided by 1 plus Yeah, you will get it as this term divided by 1 plus this term only. When you are rearranging, you will get like this. So all of you parallelly you try. Now C by R. So here it is C, here it is R. You are getting the transfer functions like this. Now what you need to do is you have to use the signal flow graph method. It is very simple. This problem also very simple, so you can easily understand it. Okay, so here we have to transfer the first block diagram into signal flow graph. So this is the block diagram. You have to decide how many nodes. Wherever there is a branching, there should be. From here again one more node multiplied by and C. Here also one more node, and that is multiplied by 1, and after that before that R. So you should be very carefully, you have to convert it. All of you now only you convert the block diagram into signal flow graph. It is not very tough. You clearly, if you observe it, you can see that the signal flow graph you are getting like this. So here G4, then G2, G3, here it is 1, here it is 1. Wherever here it is G1, 1. See, I told that wherever, yeah, from here the deviation is taking. After that, after the summation point, you should put a 1. Here so many points, so here also 1 we are multiplied by, here 1. That you should be very careful which all places we put 1. Yeah. So from here 1, then this node. From here, after this 1, then this node, like that. From this is one node and this is another. In between there is a 1 multiplications. Here also from here to here 1. After this, this is also node, this is also node, like that. Here also this is node, this is also node. Here multiplied by 1. So there is no like this a term. We are, if it is not there, you have to put a 1. So see now as you can see that the signal flow graph you are getting like this. You have to identify how many forward path starting from input to the output. So there are when you are looking it, one is very straight. Here it is arrow is opposite. It is also opposite. Here also opposite. But here again it is a forward. So you can have one like this and another is like this. So you are having 2 forward path that is represented here. Now you have to find the loops. How many loops? This cannot be considered as a loop because here also forward, here is also forward. Loop means starting from a point, go to some other point and coming back. That is known as loop. So could you tell me how many loops are there? One is like this, another is like this, and another is like this. So I think that loop 1, yeah, loop 2, loop 3, loop 4, loop 5. So 5 loops are there. How it is happening is, see, only explain like this: 1 like this, 2 like this, yeah, 2 like this, 3 like this. Additional to that, 1 like this, another is from starting from here, this way, and this way. So you are getting, once more I'm telling, starting from here, this way, this one. When you're taking this is coming like this, coming back. Then another one is normal one, like this, another is like this, another is like this. So here you should be very careful, because there is a chance to make mistakes. So you should be very careful when you are dealing with this. Now you are having how many loops? I think that 5 loops. Having 5 loops. Yes. Next, what you have to do is, as per the 2 forward paths and 5 loops, and whether there is any non-touching loops, any 2 non-touching loops. There is, I think that there is no non-touching loops. All the loops, if you are considering this, that will be touched with all other. So there is no non-touching loops. There is no pair of 2 non-touching loops or pair of 3 non-touching loops. So normally that is not there. And next we will see the gain of forward path. The forward path 1, the gain is this one, M1, and forward path 2, the forward path gain is this one, and forward path M2, the gain is this, and there is no overlapping loops. So delta 1 is equal to 1, delta 2 also 1, corresponding to the forward path 1 and forward path 2. Now the loops L1, L2, L3, L4, L5 gain, you have to find it. Just multiply all the terms. You see go through the loop. What are things you have to multiply it. You can see here. Now the determinant, that is equal to, because since there is no non-touching pair loops or non-touching, you can directly only this is expression delta is 1 minus L1 plus L2 plus L3 plus L4 L5. So you're getting delta like this. So C by R is equal to, as per the Mason's gain formula, C by R is equal to M1 delta 1 plus M2 delta 2 plus delta, that is equal to, you can just substitute it, you are getting the answer. So just go through it. These are the loops gain. These are the forward path gain. This very concentration should have to find the forward paths and loops. We may think that it is only 3 loops, but it may have 5 loops. Okay, sometime you may think that it's 5, it may be 3, like that. You should be very careful when you are dealing with the finding the loops. And here in this problem, there is no overlapping, there is no non-overlapped loops. So as per the Mason's law, you already studied Mason's formula. You should very clearly try to understand that. Yes. It is very easy to understand that. Yeah. Yes. Mason's formula. I think that you already studied. Okay. There is no need of explaining again and again. But still, in order to give a continuity, Mason's formula. This is an example they are explaining. See here. This is the formula. T is equal to sigma k mk delta k by delta. So T is equal to sigma k mk delta k by delta, where mk is the path gain of kth forward path. So if it is 2 means two terms, 2 forward path means this will become k become 2. So you are having 2 summations. Delta k, value of delta for that part of the graph not touching the kth forward path. So you know that you already be